Okay, so welcome to lesson one of my refresher course. So we're going to talk about factorizing today, factorizing and the factor theorem. If you have any questions, you can just put them in the chat. I also have this something I'm getting used to here. Yeah, so I may ask you to, I might bring up this screen here if I want some feedback from you, if I want to do a poll. And I'll ask you to scan this QR code here, and then you'll be able to like answer yes or no or vote for something in a poll to just make the lesson a little bit more interactive. Okay, so the first question I want to ask you is what you think about when we say the word factorize. So what do we actually mean by that? And maybe we can try this out actually, see if it works. Or you can just even put it in the chat. Yeah, we can just put it in the chat if you have any ideas of what we mean by factorizing. But essentially, what we're doing is we're sort of breaking down something into a bunch of sort of smaller numbers that like multiply to give you back that original thing. So it could be like, for example, we could take the number, let's say 8, and we could say, so let me get the pen here. We could take the number 8 and we could say that that's like 2 multiplied by 4, right? So 2 and 4 are factors of 8, and then we've written 8 as a multiple of its a multiple of factors. Or we could have something sort of longer, like 2x plus 4, and we could say that that's equal to 2 times x plus 2, or x squared plus, let's think of something real quick. So 5x plus 6, this is equal to x plus 2 times x plus 3. And in the act of factorizing something, we're making it clearer, we're making it simpler, right? Okay, so we're breaking it down, and then we're going to be able to do more things with it, right? We're going to be able to use it or solve problems. So this is a very sort of basic thing that we want to be able to do. Okay, so let me just have a think for a second. If we look at these following factorizations here, basically one of these is incorrect. Okay, so the first one here, I'm factorizing it into the set of brackets. I just did it on the previous page. The next one here, this is like the difference of two squares, right? And then I have my answer here on the other side. Then this one here, this looks pretty good. So, and this one here, okay, the 4 by the 2 is equal to 8. The 4 plus the 2 is equal to 6. Everything's a plus. So this one's okay. This one is certainly okay. This one is certainly okay. This one here has like two problems. Okay, so the first problem is that, well, what we really need to do first of all is we have to say that this is x squared minus 3 squared, right? Because it's a difference of two squares, and then that'll be equal to like x minus 3 by x plus 3. Okay, so it's just a quick warm-up type question to sort of see if you can kind of, sometimes you don't see these kinds of mistakes. Okay, so as we do these problems, so let's say questions like this will be one type of factorization problem, right? This will be another type of factorization problem here. Then we have quadratics, and then we have sort of cubics. So if we're doing a question that involves factorization, we're going to have to look, first of all, for a common factor. Is there something that we can take out of brackets? Like in the previous problem, 2x plus 4, we could take a 2 outside of brackets, right? Okay, so the next thing that we look is we check for a difference of two squares, or we look for perfect squares. We'll talk about perfect squares in a couple of minutes. So we would be looking for like two terms, right? One of them squared, one of them a number, for example, for the difference of two squares, or a perfect square, like if we have something like x plus 2 all squared, then we get, becomes x squared plus 4x plus 4. If we have x plus 3 all squared, this becomes like x squared plus 6x plus 9. So we're seeing something with this 4 and 4, and we're seeing something with this 6 and 9. Let's do another one. So x plus 4 all squared is equal to x squared plus 8x plus 16. So we're seeing something with the 16, and we're seeing something with the 8. The first thing that we see is that all these numbers are all perfect squares. Like 2 squared, 3 squared, 4 squared. And the two numbers are adding to give the middle number. So that's how you can always see the perfect squares, right? So these ones, maybe these can be shorter than having this sort of longer method. Okay, so looking for a common factor, looking for the difference of squares. So now we're also looking for this trinomial pattern, which will always be like the ax squared plus bx plus c. Okay, so this is just a classic sort of quadratic type of pattern. And this a at the front, junior cert level, maybe this is always a 1, or most of the time it's a 1. It doesn't have to be 1 anymore, and it doesn't have to be positive either. Okay, so that's what makes these questions a little bit more tricky. And then for cubics, obviously you're going to be leading with a cubic term, bx plus cx plus d. Okay, so these are the different sorts of flavors that these types of questions can come in. And then we're going to talk about the factor theorem in a moment. Basically, what happens with the factor theorem when we apply it is that we basically take one that's a cubic and we convert it into one. We kind of turn it into a linear times a quadratic. So we can kind of go from this type to like this type. Okay. Okay, so I'm going to do a few quick examples. And sorry, I'm going to do a few quick examples on these ones here. And as we do them, we just want to apply these sorts of methods to see what types. See where I am. So these are the things we're looking out for, right? Is it a trinomial? Is there a common factor? Is this the difference of squares, and so on? And once I know what type that it is, then I'm finished sort of diagnosing it, and then I can launch into sort of solving. Okay. So just ask yourself in the first place, okay, which type this is. And in a way, it looks like a quadratic, right? But what we can see is that there's an x in the first term, and there's an x in the second. There's an x in the second term, and if we take that x outside brackets, then we have this thing. And you might be thinking, like, is this the right thing to do? Like, would I be going wrong? Maybe doing this is certainly not wrong. And the rule of thumb in maths is if something's not wrong, why not do it? Like, it's not a wrong thing to do. It's not incorrect in any way. So go ahead and do it. And then often, as soon as you do that, you're almost there. Now, with this question here, are we finished factorizing? And what we can see is that actually there's a 3 in this bit here as well. So we could take a 3 and an x outside. We're left with 2x plus 3 here. Now, some of you may want to jump straight to here, right? And this is kind of what I always sort of think is like, this is like going up a set of stairs and taking 2 steps at a time. Sure, you can do it. Sure, most of the time there's no problem. But every so often you sort of trip. And really, you're not getting much of a time saver skipping intermediate steps. Usually it just makes sense just to do the intermediate step. Your answer is just a slightly bit longer, but you don't lose too much time, and you have the added security of knowing that like you didn't go wrong. Okay, so so this one is a difference of squares example. The first thing I want to do is I want to take that first term and write it as a square. Okay, I'm already in luck. And the second term and write it as a square. And then what I'm going to do is write this as 2 sets of brackets. I'm going to take that x and the 7, x and the 7, minus and plus. And what we can always do if we're unsure, if we're doing the right thing when it comes to maths, is just like multiply everything back out again. So if I was multiplying everything back out again, I would multiply that by that, this by this, and this by this, right? So then x squared minus 7x plus 7x minus 49. And then what we end up getting is they cancel, and I end up with this x squared minus 49. Okay, the next one. So this is a trinomial. People have different ways of doing this. The way I have of doing it is I just draw 2 brackets to begin with. And what I'm going to do is take this first number and say that it's, what are the 2 numbers that could multiply together to give me this 2x squared? Well, they're 2x and x, right? So this will have to be 2x and x here. Okay. And then for this second number, what's the possibilities? Well, there's 1 and 3, and there aren't any other whole number of possibilities. So I'm probably going to have to put a 1 here and a 3 here, or a 3 here and a 1 here. Now, I know I'm saying this, probably you're all completely okay with this, but what I'm trying to get across to you is just sort of the methodical way in which you do these things, right? So it's always like, it's like, you know, everything's already got, it's like kind of robotic in a way, right? So it's sort of like, okay, what kind of problem do I have? Okay, what's my next step? This is the kind of training, kind of discipline that you want to be able to build up. Okay, so we can see anyway now that we needed 2 numbers that multiply to give us the 3. So these 2 numbers here. Now if we multiply the 1 by the x, we'll get 1x. The 3 by the 2x, we'll get a 6x. So that 1 plus 6 then will give us a 7x. Okay. Now, a quick note on perfect squares, as I was saying before, what you're looking at with perfect squares, we look at these different examples. It's not always the case. We will see some in a while that aren't the case, but each of these numbers going down the list is a perfect square. So that's like 3 squared, 5 squared, 3 squared, 4 squared, 5 squared, and 3 squared. Okay, and then coming up this side here, these are also perfect squares as well. This is x squared, y squared. This is 2m squared. This is 3p squared. A squared, this is 5q squared. And then if we see this number in the middle, well, that's going to be like the 3 plus the 3. This will be the 5 plus the 5. Now, the 12 isn't the 3 plus the 3, right? But if we go ahead and sort of, we suspect that it is, we're going to say it's a 2m plus a 3, and that's all squared. So that'll be multiplied by 2m plus the 3. So we have the 2m by the 2m. So when we multiply it out, we have the 2m by the 2m. That's like 4m squared. We've got the 3 by the 3. That's my 9. And then we have the 2m by the 3 and the 3 by the 2m. That's plus 6m plus 6m. Okay, so that 12, the reason why it's not the sum of the 3 and the 3 is because of the number that's here. Okay, so that can throw you off a bit. In this example, we have a minus, right? But these difference, this sort of perfect squares, the second one doesn't have to be, like, see, this is x plus 3, but in this second example here, it was x minus 5. So that's why we got the minus 10, because when we added the minus 5 and the minus 5, you want to get kind of, let's say, good enough at sort of spotting when it's a perfect square, because you have a sort of a shortcut. You can still use this previous method to get there, but it's just it's good to be able to kind of spot things when you know, to sort of, so that they jump out at you when you see them. Okay, so the next thing about the next example, I just want to talk quickly about the factor theorem. We're going to go into cubics now. And if we have some long cubic like this one here, what we want to do is usually sub in plus or minus 1, plus or minus 2, or plus or minus 3 into our cubic. And one of these numbers, sorry, someone's joining. Here we go. Hi, someone just joined. And one of these numbers, when we sub it in, is going to give us a 0. So we'll have like f of x is equal to our quadratic. Let me just sort of, our cubic. Let me just make one up. Like, this is just like totally made up example. Or maybe I can take the example from the next page. Minus 4x minus 4x minus 7x plus 10. Now we're going to try on the next page, we're going to try to do like f of 1, f of minus 1, f of 2, f of minus 2, and so on. And one of them is going to give us equal to 0. And that's going to mean that a is a root, whichever one we found, 1 or minus 1, whichever one of these we find, a is a root. And this tells us immediately that x minus a is a factor. This has to be one of those sort of knee-jerk things. You know, it's not, you don't even think about it, right? You get like 1 is a root, then x minus 1 is a factor. Okay, and then we divide that in. So let's have a look at this example here. So we can call it f of x. You know, if it helps us a little bit, we'll try f of 1. So we just sub in a 1 minus 4 minus 7 plus 10. Brilliant. We actually found the first time the 1 plus the 10 is 11, and the minus 4 and the minus 7 together give us a minus 11. So that gives us equal. So we have f of 1 is equal to 0. So 1 is a root. We'll be talking about roots next week. And that means that x minus 1 is a factor. Now, this stuff here might be all totally basic for you. The purpose of this course is really just kind of like a warm up for you guys going back to school. Okay, so yeah, so that if it's it may be a little bit basic, but nonetheless, it's hold on a second. I have this line here. Okay, so now what I'm going to do is I'm going to divide this in. This so once I get one of the factors, so x minus 1 is a factor. Now I can divide it into the rest of the x cubed minus 4x squared minus 7x minus 10. So now I can divide it in to the rest of the cubic. So how am I going to divide into the rest of the cubic? Well, what I have to do is I have to look at this number here. Okay, so the leading term in this polynomial here. Now, it can happen that your cubic might be something like this, x cubed minus 4x squared plus 10. It may not have the linear term, in which case we sort of have to write it down like how would we write it down? Like this. Okay, you have to kind of leave space for the missing term, or else this division thing, the way we lay it out, won't work and will go wrong. Okay, so just bear that in mind, that if there is one of those terms missing, that you would have to kind of leave space for it. Okay, so we look at our leading term, okay, and we ask ourselves, what number can I put here that when multiplied by this number here will give me also an x cubed underneath? So what multiplies by x to give us x cubed? It's x squared. Okay, so I multiply the x squared by the x to give me an x cubed. Then I multiply the x squared by the to give me a minus x squared. Let me just continue that line all the way. Another thing I also do is like continue the line down. These are really kind of bread and butter things, but it's like just your layout can really kind of punish you, you know? Okay, so I'm going to subtract those two. So I'm going to subtract this line here from that line. So let me just go ahead. If I'm going to subtract, that would mean change the signs of these two, right? So that becomes 0 here. And then this becomes 4x squared minus 4x squared. This becomes minus 3x squared. And then I'm just going to carry down the other two. Okay, so what do I do now? So many times in maths, the answer to what I do now is just what I did before. So what did I do before? Before I looked at the leading term, and I asked myself, what number would I put up here that would multiply by this number here to give me the same thing? So that would subtract off and give me 0. This time I'm going to do it here. I'm going to ask myself, what number do I put here so that when I multiply it by x, and the answer to that is a minus 3x. Minus 3x times the x will give me a minus 3x squared. So let's go ahead and do it, minus 3x squared. But then I can't forget to multiply by the other number, plus 3x. And then what happens now? We subtract. Okay, so if we're gonna subtract, I'm gonna make these signs. This will become plus, and then this one here will become a minus. Okay, so then this gives me a 0. This becomes a minus 10x. Just want to move all of this up. And now we have the same problem again. And I also bring down I have to bring across the line here. So, and I'm going to bring down that minus 10. And then finally, I have the same problem again. I'm going to say, what I have to find what number I put here. So when I multiply it by the minus 10, so I have a minus 10 that will multiply by the x, sorry, will give me a minus. So I have minus 10 here. I multiply it by the minus 10x, then by this one here. Where did I go wrong? Then this is going to be a minus 10. It's going to be a plus 10, of course. Where did I go wrong? X minus 1. Minus 1. Did I get a sign wrong? It's a plus 10. Okay. Sorry. That's where I got wrong. That's what we call a sanity check at the end. You're like, okay, no, something went wrong. So this was then a plus here, and this was then plus here. Then we multiply that in, and we have a plus. And now what we have is we subtract, and we get a 0. Okay. And so we have no remainder, which means that x minus 1 goes into this thing evenly. Now, it can get kind of confusing to kind of like, once you've sort of dived down in the details to like really kind of get what's going on here. But just think about this. 2 divides into 8, 4 times remainder 0. This tells us that 2 times 4 is equal to 8. So this was, I'm not going to write this out again. That was f of x. F of x is this thing. It's equal to that thing, x minus 1 times the second thing, x squared minus 3x minus 10. In exactly the same way that if 2 divide goes into 8 4 times, that means 2 times. It means that thing by that thing is equal to the thing on the division sign, right? So 2 by 4 is equal to 8. Now, x minus 1 goes into this thing this number of times. It might not look like a number, but it is a number. It's a way of writing a number. Lots of ways to write numbers, right? X minus 1 goes into my cubic this number of times. That means that this thing here, which we call a linear, multiplied by this quadratic. So linear by the quadratic gives me back the original cubic, which I had called f of x. I'm calling it f of x again to save space. A lot of time when you're doing maths, you're writing things down in a way that saves you space, okay? So we're almost there in the factorization. The fact of the matter is that we can factorize that quadratic, 2 numbers, x and x. Okay, so our possibilities now for the 10, 1 and 10, 2 and 5, they could be minus, they could be plus. We have a minus here, right? So it has to be a mixture of signs. So it has to be either minus 1 by plus 10 or minus 2 by plus 5 or the other way around. And we have to get a 3 in the end. So the 2 numbers that give us that then are going to be a 5 and a 2. And then we need a plus and minus, and we're going to go for, well, if it was plus 2 and minus 5, then that would give us a minus 3. So we're going to say a minus. So when we get to the end here, solving these things here, it really is just kind of trial and error. You need to know what are the even numbers that I can pick to factorize this 10 here. It could be 1 by 10, it could be 2 by 5, right? What are the pairs of even numbers? If you can't find a pair of even numbers, then we have a formula, the quadratic formula that we use when we can't do that. Okay? And now we've factorized the cubic into, and what we did was we started with a cubic, we got down to factorizing a quadratic, and then we could apply the previous method. So what we've done is we've taken this larger problem and we've broken it down into a bunch of steps. And you find that, for example, in this process here, following this algorithm here, we take the same, we just do the same thing. We take the leading term, we find the number here, multiply by the x, get the next line. Take the leading term, multiply by a number by this x to get this. So you go down doing it in a sort of stepwise fashion. Then we write down our polynomial as x minus 1 times this quadratic, and then we can use the previous method with the quadratic. So it's a really great example of taking a big problem and breaking it down into a bunch of little steps, okay? And if you want to become good at maths, like that's what it's about. It's not about being super smart. It's being super sort of, let's say, methodical, like in the way that you approach problems, that you can break them into smaller problems. That's the skill that you're learning from this. Okay, so here's a quick one here. Maybe I can get you to use. So if you have your phone there, we'll try this out. I haven't done this before. So if you can scan that QR code, then this thing here will pop up on your phone. And if you scroll to the third page, then you'll see this poll here. So the question is has this been correctly factorized or not? You don't have to say why, just shoot from the hip. It's okay. Just like give a kind of a guess. I'll give it a minute. It might be hard for you. Might not be able to get it to open up. Now we can multiply everything out. Okay. And if we multiply everything out, I'm just going to pick this set of brackets here, multiply the x by the x, the x by the 2 by the x, and the 2 by the 2. And then once I've done that, then I'll multiply this one by this one. So it's a bit of a lengthy kind of process. And my question to you, is there anything that kind of jumps out at you that maybe some way that you can kind of spot that this is correct or not, maybe correct or maybe incorrect, just in the first go? Just have to think about that for a moment. Sorry. Okay, so let me address that. So let's have a look at this first term here. So when we multiply this whole thing out, all these brackets by brackets, well, this x cubed term is going to come from this one, multiplied by this one, multiply this, like this one, ultimately. Like I know we'll multiply these two sets of brackets together first, and then we'll get like an x squared, and we'll multiply the x by the x squared to get the x cubed. But basically, we're going to have that x by x by x to give us the x cubed term. Nothing but x's in it is what we're saying. These ones here have a mixture of numbers and x's, but this last one has only got the multiple of all of the numbers. See, the last one has no x's in it, so it has to be just a pure numbers sort of thing multiplied by each other. And so we have -1 by -2 by -2 gives us minus, but it doesn't give us 6. Okay, so we know that this this -6, this cannot be correct just on that basis. So it's just something that, like, maybe you can kind of spot things kind of quickly. Maybe you get your sort of eye kind of trained or something like that. Okay, so so some more worked examples. Let me just think about how best to spend the time. So I have some more worked examples. Quadratic without a equal to 1. So obviously brackets like so, 2x and x. So there, that 2x and x is the only way to split up this one here. And this has to be either 1 and 3 or 3 and 1. So then we can have 1 and 3. And then that will work because 1 by 3 will give us 3. This 3 has to multiply by the 2, and the 1 has to multiply. So that's the 7. Okay, I think we had these ones. We had that one already. Yeah, we already had that one. So, yeah, so I'll move on. Okay, so this one here, this is a bunch of, yeah, so I have a bunch of sort of special cases for different types of questions. And then I have some just a few exam questions. We're not going to get deep into that yet because they try to make it awkward when you do the exam. So if we go back to what I was talking about before, was like the kind of what to look out for when you're factorizing, and you'll either have one like this, or you'll have one like this, or you'll have when it comes to the exams, like they don't give it to you as kind of cleanly as that, right? They give it to you deliberately. I call them kind of like curveballs. It's like a baseball analogy, but they always try to put a little bit of spin on the question, and you have to think a little bit more, especially when it comes to the earlier stages of the course. They don't just ask you the straight questions that you get asked in the book. They find a way to make it awkward and kind of. So let's take a step into looking at some of the more sort of awkward examples. And what I'm going to say is when we do these things here, we're going to mix a little bit from this list. Like we may do two things from this list. And you know what? We're very often going to do this one. And this is kind of like, it's just like, the most basic thing that you can do. So if we look at this first example, like this 6 should stand out to you. It should be sort of extra. you know what, I actually kind of want to write this as 6 times x squared minus 4. And then you see it. This is actually a difference of 2 squareds question, but just with that 6 that was thrown in, that makes it kind of awkward. So this is like 6 times x minus 2 by x plus 2, okay? Now I kind of think about these questions like imagine you're sort of, I don't know, like imagine this is where you're trying to get to. You're trying to get to here and you're here basically. And you basically can't see your way through to the answer. So what do you do? Well, the answer is you just take a step forward in the direction that is not clearly false. Do you know what I mean? It's really kind of a shot in the dark. This is kind of like, well, why wouldn't I do this? And the reason why I'm emphasizing it so much is because this is where you really see students kind of they kind of get lost at the start because they're kind of expecting the question to be uh, basically of a type that they've already done, that they're kind of familiar with, like they're not really comfortable with this. But what I'm saying to here is it's certainly not wrong to do this. It's certainly not wrong to factorize that bit out in the first place. And then as soon as you do that, you've gotten to the point where, okay, I can see my way now to the answer, basically. So you've sort of turned the corner, okay? That's what I call just do things that are sensible if all else fails, right? So we'll have a look in this example here. It's like I suspect that it's a difference of 2 squares thing. I could be thrown out off by the fact that that they're talking about y now. I mean, is there any significance as to like usually it's x, but now they're talking about y? Are they talking about something else? So that's one kind of maybe thing that sort of an outstanding type of issue. Also, I can kind of see a square here in the first one, and I can see the minus sign and I can see a number, right? So it's not, if we go back, it's not one that's like it's not one that's like this, where it's an x squared term at the beginning and then an x as the second thing. It's one like it's one like this, where it's an x squared and a number, and there's a minus sign. So it's probably the difference of 2 squares, but it doesn't look like it. But what can I do? I can just again say take the 10 outside brackets, y squared minus 4. Now I see it. That's 10 at y squared minus 2 squared. And then that's 10 times y minus 2 by y plus 2. And another big lesson to learn here is that you just have to, sort of sacrifice your dependence on x, if that makes sense. A lot of the time people kind of, when you move into doing maths, it's amazing how much we fixate on the symbol x being used. It's totally arbitrary. Example, in ones that come up, it really can be anything. So you have to be ready to do all the same types of stuff, even if they change that kind of thing around and not be put off by that. Now, again, this one here looks like a difference of 2 squares example, because that second one is certainly 4 squared. And I have a minus sign, but the problem is I have x to the power 4. Well, x to the power 4 is actually x squared to the power of 2. And just as a quick note, brackets are really your friend. Like, we don't like to write brackets because we like to write as little as possible, with as little clutter as possible. However, you're never incorrect to put brackets around something. And it's a really great way to kind of separate things in your mind. So use lots of brackets. It's a little bit annoying, but just take your time when you do these questions, use lots of brackets. And what we see here is we see that this actually can be written as, x squared. Let me just, x squared minus 2 squared. So we have this thing, whatever that is, squared, and this thing squared. So now we have x squared minus 2 by x squared plus 2. And it might be possible in some of these examples. Sorry, why did I do that? Sorry, I obviously made a mistake there. Let me go back. There we go. That was, this should be a 4. Right? So we have this is going to be x squared like minus 4 by x squared plus 4. Right? But we can continue on because if we look again, this here is the difference of two squareds. This is x squared minus 2 squared. That's in brackets, and that's multiplied by the same x squared plus 4. And so this is now x minus 2 by x plus 2 times x squared. And now this has been fully factorized. So if we take a number like, sort of like, let's take a number like 24. The 24 is 3 by 8. But then 8 is 3 by 2 by 4. And then this is like 3 by 2 by 2 by 2. Now we can't go any further because we've hit all the prime factors, right? So that's the same here. Like here, it's been factorized, but it could be factorized further. So we haven't factorized it. You haven't factorized it unless you've gotten right to the end and we put a full stop. And another thing I want to point out to you here is that this extra line, this makes this more difficult. Like in a way, we would sort of like to be finished here, right? But it's more difficult because we have to do an additional line. But what I want to say to you here is, so that makes the question more difficult. But what's the nature of the difficulty? It's difficult because it's longer, because we just take this piece here and we apply the same formula. If we were given x squared minus 4 at the beginning, we wouldn't have had a problem like saying that that was x minus 2 by x plus 2. So this kind of difficulty is like the same method is nested. Yes, you just have to do it twice. And that's okay. And that's good news, because when they make questions more difficult, it's better if they make them more difficult in that way, where you just have to do the same thing you just did again, Okay, so we have some more examples. I think you've probably seen it by now. So 8 times z to the power 4 minus 9. This is 8 times z squared to the power 2 minus 3 squared. This is 8. And see the way we're carrying z squared minus 3 and then z squared plus 3. And see, we did this step here at the beginning. We took this 8 outside and then we carried it. And then we carried it like the whole way along. And so once this bit is done, everything else that we care about is happening like inside of brackets. Right? Could we go further? Like we see the z squared minus 3 business. Yeah, we could. We could say that z minus, and what if 3 is 9 is 3 squared, right? So 3 is equal to the square root of 3 squared. So we could actually write it as z minus the square root of 3 by z plus the square root of 3. At this point, it might be actually not necessary. Like we may have kind of overshot, if that makes sense. And actually, it might have made sense to stop at this sort of earlier line here. Okay, so you'll kind of know from doing examples when they are, okay? With these types of questions, like, let's have a look at this one here. So, like, let's see, do I have any? Yeah, I'm going to use that one in a second. So, what happens here is that, like, this first number here and this, you might get like, okay, so 3 and 1 are the only possibilities here, but this is 1 and 6, and this is like 2 and 3. So it's either this one with this one or this one with this one. Now, if we had two different ways to do the first one, then we would have to split the problem into two different parts. I'll show you that now in a second. So with this one anyway, it's just the same as we saw before. We'll have brackets, is 3x and x. Okay, two numbers that multiply to give us 6, and that add went with this 3 multiplying by them to, so we'll just try 1. I'll put 1 and 6 here. So that's like 18 and 1. So 18 and 1 can't give me 11. So that's not right. So I'll put the 6 and 1 here. So the 3 and the 1, that gives me a 3. The 6 here is just a 6. So the 3 and 6 can't give me 11. So it's not that one. I'll try the 3 and the 2. So that's going to be a 6. That's going to be a 3. So then the 6 and the 3 can't give me 11. So then final possibility, 3 and the 2, and it's like 3 by the 3, that's a 9, and a 2, so that works. So that's a 9 and a 2. So I can get 11 from 9 and 2. Everything is plus, so I'm done. Okay. So it's just getting used to going through all of the permutations. Okay, so for this one here, this is something that again you kind of just learn to do without kind of thinking. And basically, I don't like this minus in the front, right? It just sort of spoils everything because I'm kind of like, I'm used to doing them basically never with a minus. But why don't I do this trick? Why don't I just factorize out a number and then just leave it in front the whole time, and then the rest of my work happens in brackets? So let me show you that. So taking a minus outside brackets is just something that we just do this all the time. So I'm going to take a minus outside the brackets, and inside the brackets, I'm going to have my trinomial. Okay, so if I take a minus, factorize out a minus from this, I have the same thing, but just the opposite sign. I take out a minus from this one, I have a minus 7 times m, and I take out a minus from this one, and I have a plus 3. And again, this just has to be something that you're kind of, you just do it without thinking, right? Because it's just something that happens quite a lot. If you don't like the minus sign, just take it outside brackets. And from now on, let's just write the next line. We're going to have a minus, and everything else what that happens will be inside of these brackets. So we're just going to be able to focus on this part here, okay? And that's where it helps to put the blinkers on right now. Ignore the outside stuff. Okay, so just looking at that there. And again, remember what I said, with brackets, you don't get penalized for using too many brackets. You may, you may make a mistake because of clutter or whatever, but there's nothing incorrect by doubling up our brackets here. Okay, so it has to be 2m and m, okay? And then the numbers to give us, we want to get a plus 3 and a minus 7, okay? So the two numbers, it'll have to be either 1 and 3 or minus 1 and minus 3, right? So let's try the minus 1 here and the minus 3 here, for example. Well, let's just try the 1 and 3 first of all. So we try a 1 and a 3. So I'm going to have a 6 and a 1. Okay, that's going to work. From 6 and 1, I can get a 7. But will I get a minus 7? Well, they would both have to be minus. Okay, so I end up getting this equal to minus 2m minus 1 times m minus 3. So this would be a lot significantly more difficult to do if we hadn't taken that step in the beginning. So that's what we really kind of mean, make life easier for yourself. If there's a step that you can do at the start that will make life easier, then just do it, right? Okay, so this one here is trickier again because this here can be the 4p squared could be 2p and 2p, or it could be 4p and p. And what I'm going to do is I'm actually going to split the problem into two parts, okay? So the first part, I'll say 4p and p, and the second part, I'll say 2p and 2p, because I don't know really, I mean, this is just my way of doing it. You might have another way of doing it. But I don't know really if this, and this here can be 1 and 12, and this can be 2 and 6, and it can be 3 and 4. And if nothing works, then I don't have a whole number factorization, so that means that I'm going to have to use the quadratic formula. So let me just pretend, let's just go with this here, that it's 4p and p. And let's think about this 12. Is there a way? So let's take a 1 and a 12. Okay, I get 4 times 12, 48. There's no way that I'm getting this 19. Okay, let's try a 12 and a 1. Okay, 4 times 1 is 4. So that's 4 and 12. Could work, but it's not working for me. So let me try the 6 and the 2. So that's going to be 4 times 2 will be the 8. Then 6, that's 8 and 6. That's going to be 14. That's not working. What about the 2 and the 6? So that's 4 times 6. That's going to be 24. Definitely not going to get the 12 from that. Looking at these signs, I already also know that these will be pluses. Okay, so that helps as well. Okay, so I can try now. What did I try? So this is the 4 and the 3, and that's not going to work on the 3 and the 4. The 3 and the 4, does that work? 4 times, that's 16, and then 16 and 3. That's it there. Okay. Now, if we found that nothing worked here, then we'd say, oh, well, it's not that, so it must be this. Okay. So trial and error is a perfectly acceptable method to use so long as you don't have too many different possibilities to kind of go through. So here it's how many possibilities are there? Well, there's either 4p and p with the 112 with the 26 with the 34, and or it's 2p and 2p with the 112, the 26 and the 34. And you could see the way I was kind of like putting the larger number to the right, I think it was, or something like you don't need to, you get quick at going through all the possibilities without having to check every single one. So you can use trial and error as a valid, reasonable way to solve problems as long as it's not like a really, really long list. Okay. Okay, so, and then this is just like if they ask you a question with a Q, for example, you just have to be good with that. And then I'm not too sure why. Oh, I think what happens if when we factorize this one here, we're going to find that the reason why I chose this one is once we factorize this one here, I think if we just put in 1, it'll be 1 minus 1 minus 4 plus 4. So if x minus 1 is going to be a factor. When we divide x minus 4 into a factor, we're going to get a quadratic out, and that quadratic will be, I think it'll be x squared minus 4x plus 4. So it'll be a perfect square, right? So it's just like the perfect square example can come up in different places, and you just have to be kind of ready for it. Okay, so we just have another final like a couple of minutes. I have another class starting in about 6 minutes or 7 minutes or so. So I just want to give you a quick taster of some exam questions. Just, just a quick sort of idea of like, obviously when I was going through the exam papers, I wasn't exactly finding questions which were like factorize this sort of quadratic. So these are bits of questions or, okay, so we'll just have a look at the first one. So this was a part of a question. We had to show something, and then we had to find the roots of this equation. And finding the roots of the equation basically means we first have to factorize it, and we'll talk about roots next week. So what we're going to do is just take that left-hand side, and we're going to break it into or, and then two numbers that multiply to give 8 is 16, the add to give 10, that's going to be 8 and 2, and they're both minus because that's a plus, and then this would be, and that's, and then, okay, so so just a quick thing. So we have factorized it, okay? And we actually find that factorizing is part of finding the roots. We set this equal to 0, and then we'll see this next time, but basically or minus 2. So if we have this thing multiplied by this thing to give us equal to 0, then we have two possibilities, either 1 or the first thing, right? If any two numbers are multiplied and they give us 0, it's either the first thing, like if I have A, B equal to 0, like two numbers that multiply to give me 0, it's either A equals 0 or B is equal to 0. That's not true with addition. Okay, that's what this statement means. Okay, so if two things are multiplying, giving you 0, one of them has to be 0, right? So we have two things. This thing, it's a number. It might not look like a number, but remember, a number is just something that we can put brackets around. Just think of it like that, right? So as long as we can put brackets around, this is a number, or minus 2 is the number. So we have this number multiply this number. So one of them is a 0, or minus 2 is equal to 0, or minus 8 is equal to 0. This one gives me or is equal to 2, or is equal to 8. So now this has been, so the first of all, factorize and then root. So we'll talk about this more, but these things are obviously connected, right? So it's just the same type of question, just an extra tiny little step to get the roots. Okay, this is an interesting one here. This is the kind of question that will come up on the leaving cert. So you see, you've been given something that you've never seen before, probably, or maybe you've seen it, but it's like the end of the extra questions, the tricky questions at the end of the chapter that maybe you haven't done, right? And what they've done is they've given us this M here. And then they've told us here, they're saying find two values of M for which the following X is exactly one solution. Okay, so let me show you something that has exactly one solution. X squared plus 2x plus 1 equal to 0. Why? Because it's a perfect square. And you see, it's either x plus 1, this is x plus 1 times x plus 1 equal to 0, right? So it's either x plus 1 is equal to 0, or it's x plus 1 is equal to 0. So what they've told us is that this is a perfect square. But we've got this 3 at the front, which is messing everything up. So what this really is it's 3 times x squared minus something x, something x, and plus a 1. See, I've taken that 3 outside brackets. That would really be m over 3, but I don't want to confuse things at the moment. Well, what does it have to be? It really has to be a 2. And that would be 3 times x minus 1 all squared, okay? I'm not asking you to sort of follow exactly what I'm doing here. I'm just trying to point out that this is the type of weird ways in which they'll ask the question. And now when we multiply this stuff back out, if I multiply this line back out here, it's going to be 3x squared minus 6x plus 3. So that if we were going to have a perfect square, if we're going to have one solution, we have to have a perfect square. We have to have a perfect square. And the only way that we can get a perfect square from this particular one is if that m is equal to 6. Then now it makes sense. Imagine if they said factorized. Imagine if they gave you this. If they gave you this to begin with, then plus 3. 3 times x squared minus 2x plus 1. Now you see it. So this is where it's sort of like when you get super familiar with the type of examples that I was giving you at the start, and you're really confident with this, these ones here, the kind of the strange way that they ask them doesn't catch you out. Okay, so this one here, it just I'm going to talk about this. Well, I'll be talking about it more mainly when I'm doing my main classes in September from there. But I want you to start looking at the marking scheme and figuring out what you get marks for, right? Because you might be like, I have no idea how to get this. I don't know how to answer this question. I've no idea what to do. It might mean that you can't get 10 out of 10. And my answer to you is like, my question to you is like, why the hell would you get 0 out of 10 then? You have to get either 3 or 7. If you cannot get 10 out of 10 for a question, you must get something in between. And you'd be amazed at how easy it is to get these marks here. And actually, you'd be amazed that once you're getting these marks, you actually just see it. And then you get these ones. So it's a different type of attitude. I don't like the perfectionist attitude when it comes to maths, right? Maths is much more like kind of trying things out and stuff. Final one, show that x minus 1 is not a solution of the final thing. What can we do? 3 times minus 1 all to be squared plus 2 times minus 1 plus 5 equal to 0. And I'm going to do a symbol. I don't do this on a maths course. Is it equal to 0? Right? Okay, so what we do is we just work out what that is. It's 3, like equal to 3 minus 2 and plus the 5. That's equal to 6. Which is not 0. So that means that it's not a solution, okay? I have to go there because I have the next class coming up now in a few moments. What I'm going to do is after this finishes, just after I finish the next class, I'm going to send you an email with an exercise sheet, some examples to go through to practice in your own time, and I'm going to send you the link to this class here. And then I'll remind you again tomorrow about the lesson tomorrow. So I'll remind you at 3:30, an hour before the lesson, about the lesson. Okay. And tomorrow we go on and we do like more algebra, but we do the what's called the quadratic formula, and we'll talk about roots, talk about graphing and things like that. Okay. So then I'll see you then tomorrow. Hope that was useful.